right, let's get right into it. We're all seeing these incredible, mind-bending images made by AI, right? But what if I told you the next huge leap forward in AI art isn't going to come from some massive supercomputer, but from a single beam of light? Just take a look at this. It's got style, it's got complexity, there's a real creative spark there. But here's the thing. It wasn't made by a GPU sweating away, processing tons of data like we'd expect. So if a computer didn't make it, what did? You heard that right. This was created almost instantly by light itself. Now, the big question is how? And maybe the even bigger question is, why would we even need to do something like this? Well, to get that, we have to talk about a massive, kind of hidden problem at the heart of AI today. You see, as these generative AI models get bigger and more powerful, their appetite for energy is just becoming astronomical. They need so much power, and they're leaving behind a pretty serious carbon footprint that we really can't ignore. Look at this number, 2,916 joules. That's how much energy a standard AI model can burn through to create one single high-res Van Gogh-style image. That is a wild amount of power for one picture, and it points to this huge, hidden cost of all this digital creation. To put it bluntly, the way we're doing things now just isn't sustainable. The insane power demands, the fact that it's hard to scale up, the long processing times, it's all a huge bottleneck. If we want AI to be truly everywhere, in our pockets, in our cars, we need a radically different, way more efficient approach. And that new approach, it might just be light itself. And that brings us to this absolutely brilliant idea researchers have come up with, called an optical generative model. Now, this isn't just about making AI a little faster or a tiny bit more efficient. No, this is a completely different way of thinking about computation altogether. Okay, so what in the world is it? Well, an optical generative model uses the actual physical properties of light to do all the heavy lifting of making an image. Once you have it set up, the act of actually creating the image uses practically zero extra compute power. It's like the calculation happens for free, and it happens, well, at the speed of light. Here's the big idea, the what if, that changes everything. Instead of telling a computer step by step how to draw something pixel by pixel, what if we could basically create a magical lens that could take a simple beam of light and sculpt it into a finished piece of art all in a single flash? So, how does this magic trick actually work? To really get our heads around it, let's use an analogy. Think of the digital part of this system as a recipe writer, and the optical part as a master chef who can cook that recipe instantly. Okay, let's walk through it. First, you start with a bit of random digital noise. Think of it as a blank canvas. Then, a tiny, super efficient digital encoder, our recipe writer, takes that noise and turns it into a special pattern, which is basically a blueprint for light. That blueprint gets loaded onto our master chef, a physical component called a diffractive decoder. Then, you just shine a simple plane of light through it, and bam! The decoder instantly shapes that light into a brand new, complex image. And that whole optical part? It happens in less than a nanosecond. The difference here is just night and day. Digital AI is a marathon, right? Thousands of tiny calculations, one after the other. Optical AI is a snapshot. The entire image is formed all at once. Digital AI is so energy hungry, the optical computation part is basically power-free. The jump in speed and efficiency is just massive. But the real question is, does it actually work? And the answer is a huge, resounding yes. This is not just a theory on a whiteboard. Researchers have actually built this thing. And the results? They're pretty incredible. They started with some classic datasets, things like handwritten numbers and images of clothes. And the optical model? It successfully generated brand new, high-quality images that were right on par with what the big digital models can do. This proved the whole concept was solid. So then, they kicked it up a notch. They moved on to something way more complex, creating high-resolution art in the style of Van Gogh. And again, this light-powered model was able to generate these beautiful, complex, and totally new pieces of art. And here's where it gets really, really cool. The research paper confirmed that the optical model wasn't just a copycat. It wasn't just mimicking its digital teacher. It was actually able to generate a whole range of diverse images that were beyond what the original digital model could even make. So it has its own creative flair, its own unique spark. So you can see this is way more than just a cool science experiment. The potential for this kind of hyper-efficient, light-speed AI, it's just enormous. I mean, imagine having AI on your phone that doesn't just kill your battery in an hour. Think about augmented and virtual reality that can create visuals instantly with zero lag. We could see entirely new forms of entertainment, super secure communication where the key is a physical object, and even little compact optical artists that could generate endless art using almost no power. So, what's the big takeaway here? This technology gives us a real, tangible path forward. It's a way to make the awesome power of generative AI scalable, sustainable, and accessible in ways we're only just starting to dream up.
I mean, think about it. We are literally teaching machines to sculpt with the most fundamental thing in the universe, light itself. It really makes you wonder, when our machines can create art this way, where does the technology end and the magic begin?